Hello, everybody. Sam Paluta here, Assistant Professor of Music, University of Chicago. My talk today is going to be called N-to-O Mappings of Lower Dimensional Control Data to Higher Dimensional Data Sets. And essentially, we'll be looking at a multi-mapped joystick-controlled instrument that maps joystick, a three-dimensional joystick, so X, Y, and Z, a yaw rotation, to some higher dimensional data, just to say that the instrument could use any dimensional input. So 4-dimensional or 2-dimensional input works as well, but we'll just look at the joystick today. First thing I want to do is play you some sound. So this is me playing the joystick over a data set of 4,000 little analog synth blips. So I'll let you hear this and then we'll talk about it. Okay, so this is what you were hearing. There was joystick navigation of basically a 2D PCA reduction. So this is a super simple instrument, kind of embarrassingly simple, but I think it's surprisingly effective for what's going on, and it bodes well for how some subtle changes to the instrument that I'll get to later, I think could really make it a little bit more alive. So the data set there is, as I said, 4,000 analog synth blips. So it's not overly curated at this point. I was mostly busy just making the synths, and I think the curation in the end is one of the main things we're doing here, using these corpi is curating our data sets, our our sets of sounds, and I didn't really do that much of that there. So I was just trying to make lots of them, and so that's what that is. So the analysis that I use is a mean of 30 coefficient MFCC. So it's MFCC, and then it goes into the stats, and it pulls out just the mean, and without the amplitude. So it's 29 dimensions, and then I use a PCA to reduce that to 2 dimensions. Standardize before the PCA and normalize afterwards. So, and then the mapping is super simple. So the XY of the joystick is set to a Katy tree that gives us the nearest neighbor in the XY of the PCA plot. So the yaw of the joystick, and this is just separate, is the yaw of the joystick then controls the duration of the sample. So if I twist to the left, then I get a super short samples. Twist to the right, get longer samples. There's 2 triggers. Trigger 1 turns on a looping sample trigger, so it'll loop the duration of the sample, and trigger 2 just plays 1 sample. So you can see here's my joystick, and I'm just moving XY around this scatter plot with the XY of the joystick. So here's just a little visualization of what's going on, or how I'm visualizing it. We have the N analysis dimensions that are the MFCC, and those go through the process we talked about before, go through the PCA, and are compressed down to the 2 dimensions. And really just playing the XY with those 2 dimensions. Now, I'm doing a lot of stuff in my instrument, which I'll get to in a minute, using neural networks to control synthesizers. So rather than controlling corpi, it's controlling synthesizers. And in these cases, I have a joystick, takes 3 dimensions of input, X, Y, and yaw, and then those go through they train a neural net on an N control dimension. So filter frequencies, frequencies of oscillators, Q of the filter frequency, distortion, amplitude modulation. All these different factors are all controlled by 3 dimensions of the joystick. But I see that essentially these two things are just doing the same thing, just in kind of one's backwards, right? So this starts with a big data set and we crunch it down to 2. This starts with 3 dimensions and expands out to n. Because of this, I tried one of my original models for this, which failed miserably. What I did in this version was I took the analysis of the sound and I compressed it down into 6 dimensions. And then I tried to move a bunch of faders to find samples within those 6 dimensions and then map the 3D joystick using a neural network to the 6 dimensions. This just seemed completely a waste and redundant, because if compressing the data of the multiple dimensions down to 6, why not just compress it down to 2? It just seemed silly. I thought it would work. I thought it would be really cool, and then it wasn't. But I do think that the model could get some could expand a bit. So right now we get the analysis dimensions, use the PCA down to two dimensions, and then the joystick is controlling those 2 dimensions. I think what could happen is have a hybrid model where that's going on, but at the same time the X, Y, Z of the joystick are trained on n control dimensions that happen at the same time. So a filter low-pass filter that's going over the sample set, the Q of the filter, frequency modulation on the filter, distortion, duration, pitch change, amplitude modulation. This could be anything else, so anything you can think of. So the X, Y, Z of the joystick goes through a neural net, trains the neural net on these n control dimensions, at the same time is controlling the X, Y is controlling, looking into the PCA 2-dimensional mapping. So I think that could be a really cool way to use PCA and neural networks at the same time. And then here is a second possible model that I think would work really well. So here we just take the 3 dimensions of the joystick and map it to n dimensions, where 2 of these dimensions happen to be the PCA. I think this could work. I think this runs into the problem that a lot of people have been expressing on the discourse, which is that then the PCA is just has an equal weight to these other parameters, which you just have to compensate for in the training. So the training of the neural network would need to think about that, whereas this one, the XY, is always mapped to the PCA. So yeah, I think these 2 models are slightly different and they could complement one another. So just to speak briefly of the bigger picture, because this instrument is part of a larger instrument. So the sample playback stuff is part of a larger instrument that uses all of these neural network synthesis mappings as well. So I think one of the things that is super important is that lots of mappings equals lots of options. So rather than have the joystick being mapped to one set of parameters, for each of my instruments, I have the joystick mapped to 8 different mappings. Okay, so here is the corpus player right here. It's called sample player 0. That's implying that there will be more sample players in the future, and I hope that's true. As I said before, there's 8 mappings inside the sample player. And so you can see here X range 0, Y range 0, dir 0, X range 1, Y range 1, etc. So there's 8 different mappings. Basically, here's my scatter plot of all my samples, and if I go to setting number 1 or setting number 0, it limits the area that I can play to something like something like, yeah, in there. If I go to setting 1, it's more X, Y, so it's more here. So in setting 1, if I move the right, and if I go to setting 2, so they're different parts of the sample set. Now, in the future, what I would probably do, I mean, I might have just different KD trees underneath each of these settings, or different KD trees under some settings, and just different sets of PCAs under the other. Sorry to mix up that terminology there, but I hope you know what I mean. So what I can do is, you can see me changing the which one I'm using right here. So that's the model number, and then the synth number's up here. So if I'm playing here, now that's just this instrument, and I'm triggering it by pulling the trigger on my joystick. Now my joystick has 6 buttons, so I can use the 6 buttons to control and switch between different synths. So synth number 2 here is my Pew Pew drum synth, and that's using this one's a pretty big data set. I can't count that right now, but if I move my joystick around, it changes the data in just by moving the joystick in the X, Y, and Z, and that also has 8 different mappings. So sorry about it freaking out over here. Once I switch it over to the KR version of the KD tree, it won't do that anymore. But so that one can also have a bunch of different mappings. So those are the mappings there. Third instrument is a cross-feedback synthesis. And the fourth one is another cross-feedback synthesis. Now, all of them have their own limitations, but I think as a group they actually are very musical. So I'm just going to play and move between the 4 different things. So just to review that a little bit, while the joystick can be mapped to 8 different parts of the PCA, each neural network instrument also has 8 different mappings. So you can imagine that these like an 18-dimensional or a 56-dimensional control space on an instrument has many locations of goodness. And you want to like find these little locations of goodness. And what the software does is it provides for each instrument 8 simultaneous mappings of the joystick. Now, not simultaneous, but just 8 different ones that I can switch between. So while the instrument itself allows for 4 different synthesis engines to be running at the same time, whether they're the granular corpus engine or the neural network synthesis engines. But there's 4 of them running at the same time, which I can switch between, and then within each of those instruments there are 8 mappings. So hopefully it's clear what I'm trying to do here, which is try to fit a ton of data spaces or sonic spaces, all these multidimensional spaces, and many different versions of them underneath or inside of a very small control space. So the 3D control space can very quickly and easily move between all these different big data spaces. And that hopefully in doing that, it becomes a really expressive instrument. I mean, just seeing me play, solo, and which is really glitchy and tweaky, I don't think shows the expressive nature of the instrument. It's really designed to be played with other people. Not that that's happening a lot these days. Haha. So I'm just going to add one more thought, which is this idea of live joystick mapping to audio input. So I think that this model actually provides a really clear way to map, like somebody playing an instrument, violin or something. Violin is coming in, and if the violin is mapped to the XY PCA space, I think it's pretty easy to see that all we should be able to, or should need to do, is take that XY space and make it the mapping for one of these settings. So wherever the violin is going in the XY space, that becomes a possible space to go into in one of these settings, and that can be constantly changing over time. So I hope that was clear. I don't know if it was. So hopefully I see a way for to be playing with acoustic instruments or other electronic instruments, and then to be able to hit the joystick and get a sound that somewhat maps to what they're doing. I don't think it needs to map directly, but just some kind of really vague Mickey Mousing would be super effective. Okay, so hopefully there's going to be time for questions and comments. I really look forward to seeing what you all are doing and hearing how everyone's thinking about this stuff over the next couple days. And thanks so much to the FluCoMa guys for all their work on this, because it's a really amazing project, and I'm really glad to be part of it. All right, thanks, y'all.